Hi, everybody. Dermot O'Shea here. I'm the host of the Antenna podcast, and today I'm delighted to introduce our next guest, Dr. Peter Nevermann. Peter, would you like to give us an introduction?
Yes, I will. Thank you very much, Dermot, for inviting me. It was a pleasure. Very good point. Yeah, introduction. So I got the great opportunity to join different companies along what I call the whole food chain of the mobile phone slash antenna industry. So I was a couple of years with a manufacturer for antennas, a company called Lumberg. I will a little bit elaborate on it later on. Then I was with Siemens a couple of years. I was very proud to be with Siemens around 2000, 2003, and even moved to nice California, San Diego area. So I'm a little bit envious about what you're doing actually. Was great at this time in Southern California. And then later on, I was because Siemens was not doing so well, contrary to the other Nokia's and Motorola's at this time. It was a boom time of the mobile phone industry, but Siemens was kind of struggling. So I decided to move towards Vodafone. So at the end of the food chain, to really create like test plans for mobile phones. And also, I spent then the last year, so it's a little bit of mix up when I joined which part of the food chain. And the last year, I was with several test houses. In the last 12 years, I was with Citycom in Germany, but also a couple of years in Milpitas, that is in the Bay Area in Silicon Valley, and also testing everything with wireless, so everything what has an antenna. So and then I got the like production design of antennas. So at the Siemens, I erected several EMC slash antenna labs and was leading the stuff. I got several inventions. So at the end, 60 filed inventions and 14 granted patents in this area. That's all in the mostly in the time of Siemens, because it was a boom time of the mobile phone development and changing antennas to the internal antennas and so on. And once again, and then I was able even to be at the end of the food chain to create and discuss with the manufacturers, what kind of antenna performance is important for the mobile phone industry in particular. So that's the point. And since last year, I have my own company, which is doing antenna design as offering, but also because of the history, approval and device certification in different parts of the world. So if you have a wireless and you would like to go to market, you all need to make, somehow money and to ship the device. And that's the end. So I have also have people when it becomes, for some reason, complicated. So that was a
Yeah.
very brief um, to my step. Basically,
But
but coming back, Casey, I'm a physicist. So I got a master's
okay.
in semiconductor physics, and I was in the gallium arsenide side, so which is the competition to the silicon guys. And then I moved towards my PhD. I did a PhD in Duisburg, and here already on a kind of interface between physics, semiconductor transistors, and the noise behavior at low temperatures. Low temperature is for now very important for satellite communications. All over you have very low temperatures, and you need to bridge a huge distance. So the noise contribution from your transistors is kind of important. So that was already kind of something. So I moved from the semiconductors to the RF, and then later on to the antennas.
Yeah, but like that's I got to know you from the test lab world, and you mentioned there about the mobile phone, and then the test plan and the test lab world. It's just so important to understand the all the effects that the device can be subjected to, and particularly when it comes to RF and antennas. Right, I've seen that at the test lab, towards the end of the device design, when you're going into testing and certification, the antenna is a common point of failure, right?
And in particular, at this time, when I got involved in the antenna area, this was around the 2000, when the antenna is not anymore an external or, a huge construction, but it becomes integrated in a device. as you know by yourself, all the next pieces and ground plane size and next metallic parts play a role, and that's why the antenna becomes more and more part of the whole system, which is
Mm.
difficult to handle. So that is always every time the case. If you say, "Oh, a good antenna, yeah, for what environment, for what application, for what device," and that to get this message through is, yeah, as you know by yourself, an art of its own.
Yeah, well, we like one of the comments I've often heard from people designing these products is, why does the operator care about my antenna when I'm only sending, a text message twice a month? That's what we hear a lot. Like, how would you answer? You've probably heard that one before, right?
Yes, and I always say, listen, that is a bidirectional communication. If your device try to send a message, but the base station can't hear you, I mean, even it's only a text message, if the antenna problem sucks and you have no link, then nothing is going forward. Yeah, at a
Yeah.
certain point, it gets a relation between the data rate and the how robust, how much signal to noise is. But very often, if you have no connection, then it doesn't matter whether you have only to send 3 bytes or video, you
Yeah.
know.
And even at that, quite often we see people, they plan the project to be one text a month or whatnot, but when they actually go to use it in the field, guess what happens? They like
Yeah,
use the device way more than expected
on top.
and discover more features, right? Yeah.
On
So
top of this one, yeah. But even in that case, yeah, I only need to send it. Doesn't matter if you have no link. So antenna is an important part, and the network providers are very very keen to look or looking at this. And it's a different. I could elaborate another 2 hours on this. There's a difference between US and Europe. And US, the network providers had much more power, but also got more the pain if you in the middle of nowhere have no connections, and on your map it says, okay, you should have a connection. And on the other hand, they are allowed to block you, and Europe's a little bit more different, but that's an issue many people are not really 100% aware of.
yeah. No, for sure. They just expect it to work right. So and they blame the operator if it doesn't work. So hence the operator wants to maintain his network branding, right? And make sure
It's
we all have.
reputation. They have to make
Yeah.
sure that you have a good mobile phone. So, and in particular, if phones are sold in the millions, there's a huge pressure on the antenna performance. So that is a kind of a separate world, I would like to say, to keep up with a good performance in your mobile phone world. Yeah.
Yeah. And I've, personally kind of stayed away from the mobile phone business because it's just tough to make money in it, right? But I
Yes.
see a lot for us there's a lot of innovation for the antenna business and industry that comes from the cell phones, right? Because you're so challenged when you have to fit all those products into such a small space with everything else in there, right? How do you like from your experience, like how has that worked with the cell phone, manufacturers? How do they approach the project? Do they respect the fact they need space for the antennas, or is it just like jam in there whatever you can and hope for the
No,
best?
that's a good point. That's a good point. What the mobile phone industry is using is meanwhile different contacts on the antenna and different contacts on the chipset to and even some intelligence matching in between to to handle the fact that you have less volume but a large number of bands. I do, by the way, consulting, advertising mode on. I do consulting, how they do it and what you can do in the IoT world and what not. End of advertising mode. Because there's a lot of things which are patented, which you can't really use if the patent is too new. And also from a technical point of view, just recently, even in the module world, you have more than one RF contact available and even can switch maybe between bands. So there's some interesting concepts meanwhile to mitigate the problem of the many bands. But it's only partly what you can move to your business basically if you have modules and you have antennas.
Yeah. Like
Keep
we'd
them
see like
separated.
yeah, in outside the cell phone arena, people generally, don't want to get into too much complexity. So they create the
Exactly.
space
Yeah.
for the wide band antennas. But in my cell phone today, then am like how are they implementing cellular? Are they using switches? Is that how they're
Yeah,
getting
not only
around?
switches, but you can switch contacts and you can switch from different types of matching.
Okay. So
But
explain that. Yeah.
yeah, but you need access to different like feeding points at the antenna. It's the same antenna. You can use one antenna, but with different feeding points. But you need
Okay.
also access to different RF interface points at the chipset level.
Yeah, which you can't do with the module on the IoT level. So you don't have
Exactly.
that.
Exactly,
Yeah.
exactly. So, and here, volume, as you know, volume helps. Volume, volume, volume. So, for that
Okay.
means the geometrical size of the antenna, not volume in terms of numbers.
Yeah. No, interesting area. So you're a physicist, so that definitely that the world of antennas is all about physics, right? At the end of the day, that's
Yeah, but
and
semiconductor physics in the RF world, and I had to learn a lot, I have to tell you. So it was quite interesting. So I'm always interested in new stuff. And frankly, in particular, you have no, or at least at my time, and I was not aware of any special courses at the university teaching you an antenna design. It's not
mm,
really common. I do not know whether that's as of today possible. So that's why I was very interested in because it's new for everyone. So it's new where the others don't have really an advantage, and that's the reason why I moved once I got my PhD in the field between RF and between semiconductors more to the RF world. And then I joined the IMST at this time, the Institute of Mobile and Satellite Communication Technique in Germany. Still exists. It's like 100 people, very high competent people doing development. So it's like a big engineer bureau, what we say in Germany. So, and those people, even at that time, they had different tasks like developing antennas. So I got in this way into antenna design, and then later I joined Siemens, became even the leader of the groups designing antennas, but also testing EMC and testing antennas. So that was my way. Then then after the IMST, I moved to Siemens and become the responsible for the antenna development.
very good. And so you've worked on a lot of different projects across the world and a huge variety of projects. What would you
Yes.
say is the coolest application you've worked on, or something that you're really proud of yourself that you could talk about maybe?
There's a lot of things, but I would like to mention two. One, and that was with Siemens time, and it was a time, as you can imagine, from the external, like wired antennas, it comes to stub antennas, and then we had the task, and then it starts design first. You know, in the very beginning, it was about performance and it has to work, and then okay, design first, and then they would like to have a stub antenna, but small, as you know, that's already an issue of its own. And then please not a cylindrical, but an elliptical cross section to make it nice and shiny from a geometrical, from a appearance point of view. And we ended up in defining an antenna, which is on the one hand the helix, and the other it was an old time two GSM bands, so you know two resonances. But to make it as a push band antenna, not a wire, but making like bands on the band in the other end and the other arm in the other piece in the other direction. And this tool, and here come to the company Lumberg, to make such a tool, the credit goes to the very skilled people from Lumberg and Charles Müller, that is a push band guy, who makes a tool to produce the stuff in millions. At the end, we sold more than 35 million of the thing. And it was only a push band part with, of course, an integrated contact, pressure contact, and a piece of plastic as a holder. That was perfect in the performance. You know, stub antenna with the push band and with the three-dimensional form, it was a good performance. It fulfilled the requirements from a design point, from an appearance, from your marketing point of view, and it was cheap like hell. So that was
Okay.
one I'm
You
really
achieved the
proud of.
dream of every customer we have. Yeah, it
That
worked
yeah,
great. It was small and
it
it was
looked good.
cheap.
It looked
Yeah.
good.
Oh
I
wow,
can tell you.
you ticked all the boxes.
And another thing which is more from a scientific point of view is even in the time 2000, 2001 or so, I filed a patent application for a switchable antenna, as I told you, which is now you have to have it in the mobile phone. At this time, it was not really possible. But you know, at this time, like Siemens was, you know, negotiating every 2 years with, at this time, Nokia, Motorola, the other big manufacturers. and they made a cross-licensing agreement when it came to patent. So everyone was urged to write patents and to put it on paper. And then I think every 10 years they printed it out, put it on the scale. Oh, it's almost the same. That's fine. Let's make an agreement, because the idea was to boost the business and to produce and develop, and not to meet and suit each other. So we made a lot of patent, and this even it doesn't make it to become a patent, because at this time Nokia was faster than me. What a pity. Okay, but I'm proud of this, because these old concepts, guess what? What I now see in those
See it,
kind of
see it in there. Yeah,
devices where volume and number of bands crashes, these requirements. This concept is old enough, so you can use it, but it's old enough, and it's essentially then became a Nokia patent. But that is I was proud of, because we had already solutions which are still, as of today, very helpful.
very good. Yeah, well, that's really interesting. It's nice to see it in action there today as well. But yeah, the patents. I always struggle with the patents, right? In antennas. I'd love to hear your opinion on this, because you spend a lot of time, filing a patent, and then it's still easy for somebody to copy your product if they want.
Yes,
They
yes.
can get around a patent relatively easy. So do you think would you think it's valuable for engineers in our industry to file patents on their designs
Yes,
for that reason?
yes, yes,
Yeah.
definitely. Yeah, it's cumbersome, it's work, but on the other hand, um, I do also consulting on patents and also patent claims or patent fights. It is what you as engineers need to learn, that the view of the legal part is that the what they call the height, what is necessary as an invention to be considered as patentable or to be a patent, is quite low. On the other hand, there's a lot of other solutions you need to have. The lawyer saying you essentially know everything else, what you do not know, but you could know because of publications and so on. But it's only a slight step to really be able to get a patent, and that is if you are in this industry still as of today a high value, I believe, a high value.
Okay.
Yes, it's difficult to enforce it, especially if it's not in US or in Europe. Yeah, but since this market also its devices when they become successful in the market and there's money behind, then they tend to be also appear on the American and the European market. So I believe, yeah, it's cumbersome, it's spending time, it's effort, but it's at the end it's worth. I have seen a number of problems or fights that people still using whatever they think they can use, which is not true, and put it then later in a product, and later got the problem.
Yeah.
That's still there,
Yeah.
and that costs money usually at the end. All the lawyers, if they see patent, it's magic. Oh, come away. You need to make an agreement. It costs money at the end, and this money is usually higher than what you need to spend to really file a patent. That is the question. But you're aware that there are other ways, like you can public inventions that yeah everyone can use it, but nobody else can forbid you to use your invention.
Yeah. Yeah. No, that's a great point of it may be cheaper and quicker to do the patent application than get involved in defense and strategy around, what
Yeah,
happens
or
later.
or
Goes
or you
market.
do a paper and publish it. I mean,
Yeah. Yeah, good point. Yeah, that's something that anybody can do, right? If they're in university or in a new job or working by
yeah,
themselves, they can do their paper, and it gives them
yeah.
some protection. Yeah. Okay. Well, look, here on the Antenna Podcast, Peter, we like to do a technical topic as well. Each guest picks something technical that they can talk on for 5 to 10 minutes, and just inform the listeners and viewers on a technical topic in our industry. So I'll hand it over to you.
Thank you. Yeah, I have a kind of, let's say, baby or an important topic. What me bothers all over the time is, which is called in Germany self-interference. I think you call it noise management. Other people do it like sensitivity problems or whatever. it is not directly related to the antenna performance, but always the antenna got the blame for bad receiver sensitivity. And the problem what I have always to tell the people, do you know, and then I got the task, okay, you should make your antenna 3 dB better because we have too bad sensitivity. I said, okay, if I do the antenna 3 dB better, just in case it would be possible to get a 3 dB higher level of the base station signal. But if you have a noisy system because next to your antenna is a chipset, which is I call it from antenna point in silicon baked nightmare. So, and they radiating at the same frequency. Guess what? The antenna is picking up also this signal 3 dB better, and your signal to noise ratio is exactly the same. The problem is there's a reason, and the good point of view in the beginning, look in the mobile phones. They have 5 very complicated shielding cans, not over the RF, over the digital parts, over the nasty processors, over nasty other noise-making devices to block the noise coming out. So that is something what I always struggling with, because many people are doing normal standard electronic. You get told from the chipset suppliers, yeah, you take our good chipset and then buy an antenna from Tower Glass and you're fine. Sometimes, but sometimes not, and then the trouble starts. And that at the end, if the whole concept is already done, and especially in the world of the IoT, the people who don't really have enough capability to get a noise reduction, like for the famous DC-DC converter, a DC-DC converter, gentlemen, is the natural enemy of any wireless system. So then clock, displays, all making a lot of noise, in particular in this frequency what you're using. You can't simply filter that out, it's not possible. And here it comes what it has to do with the antenna. The first thing, you can do a lot with the antenna positioning, placement, distance, making a distance. If it's not possible, you get a huge problem to filter and to shield it on your on the area, of your device side. And that is often overlooked, and that is not really. And I explain, gentlemen, everyone can have a look. You grab your FCC ID, go to FCC. You can look in your mobile phone or in the wireless system, which get once a certification for you being used. There's a filing internal photos. Look at that. It's very important. You should do that. And once again, that's not directly linked to the antenna. Yeah, it's to the device concept, where to place the antenna, and maybe also some types of antenna, like more dipole structures or less sensitivity as a pure monopole, because the ground plane is directly close to the nasty chipset and so on. And that is something people that's very often overlooked, is the case that you try to put a very high sensitive receiver next to a normal electronic, and the people claim, yeah, and every CE and FCC think, guys, those limits for the like unwanted radiation of a normal electronic was once made without any wireless system in mind. So if you translate this like 30 dB microvolt per meter in a power, then you end up at minus 60 dBm level, what you're allowed to produce with your display, for example, minus 60. Your sensitivity of your chipset is at minus 110. That is, 50 dB difference, 10 to the power 5. Doesn't help you. So that's a topic of its own. And once again, not directly the antenna is guilty, but the concept, where to place the antenna, distance, and the rest is indeed on the device side, on the electronic side. Don't underestimate the self-interference stuff.
And is that where, like, when especially with your test lab experience, is that where you see the issue? It's not the antenna, it's the self-interference.
Yeah, it is. And if you have a strong interaction, by the way, you also end up with harmonics. So the harmonics and the self-interference is the two key problems of the IoT industry. If they, what was my last business the last 12 years? Got some people showing up the first time seeing EMG chamber going to test, and they have harmonics and they have terrible sensitivity, which is, by the way, in the US market, a no-go. Network providers, if they don't like it, You got a problem.
Yeah.
So and then what to do so, and then it comes to my other offers. I had even created a small box like 80 centimeters, what your WT is 80 called. You can roll it in every office because it goes through a normal, not lab, a normal office door. There's a small chamber with good absorbers in, 6 circular pulse antenna. So you put your device in and look from all sides what is coming. Don't mind the polarization, get everything. That's why it's circular polarized antennas. And then you can at least have a picture how bad or how good your sensitivity is or your performance of your system. So there
Okay.
exist measurement setups extra to tackle those two problems. It's the harmonics and the self interference, and both is an interaction with your antenna, which is close enough to your unshielded electronic.
Okay. Yeah, very good. Well, I've certainly seen that myself in over the years.
Yeah,
It's noise interference, people, and you look at the specs of all individual components and radios and parts, but you never can predict how they're all going to behave when they're together, as
yeah, and in
neighbors.
particular, if you look like your processor, you have a lot of data sheets, but it doesn't tell you at what is the unwanted radiation at 1.8 or 9 gigahertz. That's a point. So that's not
Yeah,
in the data sheet. And if you put it too close and then the thing is too nasty, you run into problems. I mean,
yeah,
if you sell to the people like also the antennas you have with a long cable and a long distance, fine. Distance is a good solution. But there are a lot of devices where you can't really create enough distance between the antenna and the unshielded electronic.
yeah. And the bad news for engineers is AI does not solve these problems. So you need people like Peter to help you.
To find out, yeah. Once you get the data, then you can. First of all, you need some. Okay, you need some experience actually. Still, okay.
Yeah. No, that's what it is, right? You see, it's the same problems often pop up as well, the same patterns, the same
Yeah.
behaviors, and seeing those helps you with the next project. And Peter, like where we know, like I think all across the world, all across our industry, we have people that are challenged with these problems. How can they find you if they need to reach out for help in this area?
The best thing is over my website that is like PN, like me, Peter Nevermann, minus WT, wirelesstechnology.com. PN
Okay.
minus WT.com. That's the best way.
Yeah, and we would definitely recommend you. So listen, Peter, thanks very much for the time. Really appreciate you having you on. I'm Dermot O'Shea, host of the Antenna Podcast, and we'd like to thank Dr. Peter Neverman for his time today. Thanks, Peter.
I, I thank you have the pleasure to be here. Thank you very much.